So welcome to this session on apcalculus. You'll learn about the washer method and how to find the volume of a solid obtained by revolving a region about the x-axis, the y-axis and about a line y equal to c. So the washer method is used when you have to find a volume and when there is a gap between the region and the axis of revolution. That is, when you rotate the region, if there is a gap, we use the washer method. Otherwise we use the disk method. So volume for a washer method is pi times, if you are integrating with respect to x, it will be integral a to b outer radius minus inner radius the whole square. And if you are integrating with respect to y, it will be pi times integral c to d, again outer radius squared minus inner radius squared dy. So let's start with a few problems. Find the volume of the solid obtained by revolving the region bounded by y equal to root x, y equal to 0, x equal to 1 about the x-axis. So this is the curve x squared equal to y, this is x equal to 1 and this is y equal to 0. If you rotate it about the x-axis, it will come down, and we use the formula volume is pi times integral a to b r1 squared minus r2 squared dx. The outer radius will be just we are integrating with respect to x, so x equal to 0 to 1 and the outer radius is this, so it will be root x squared, that is x. So it will be pi integral 0 to 1 x dx, integral of x is x squared by 2, and when you substitute the limits you get pi by 4. Now question 2 is find the volume of the solid obtained by revolving the region bounded by x equal to y squared, x equal to 4, y equal to 0 about the y-axis. So this is y squared equal to x, this is x equal to 4 and this is y equal to 0. When you are rotating about the y-axis, you get a gap here, so we use the washer method. So it will be pi times, volume will be pi times, if I take the y limits, it is integral y equal to 0 to 2 and the outer radius is just 4 squared. So it is 4 squared dy. The inner radius will just give you a gap. So that is 16 pi, integral of dy is y within the limit 0 to 2, which is 32 pi. Question 3 is find the volume of the solid obtained by revolving the region bounded by y equal to x squared, y equal to 4, x equal to 0 about the x-axis. So this is x squared equal to 5, this is y equal to 4 and this is x equal to 0. So when you rotate it about the x-axis, it's basically a disk. So it will be pi times integral y going from 0 to 4 and the outer curve will be your x equal to 0 to 2, that is 0 left limit to right limit. Top limit will be, the outer curve will be 4 squared minus the inner curve will be y equal to x squared. So it will be x squared the whole square dx, that is 16 minus x raised to 4 dx. Integral of dx is x and integral of x raised to 4 is x raised to 5 by 5. So your answer is 128 pi by 5. Okay, now next question is find the volume of the solid obtained by revolving the region bounded by y equal to root x, y equal to 0, x equal to 4 about the line y equal to 2. So this is y equal to root x, this is x equal to 4, this is y equal to 0. You are rotating it about the line y equal to 2. So it's a washer method. So it will be pi times integral a to b r1 squared minus r2 squared dx, or pi times integral c to d r1 squared minus r2 squared dy. So that will be pi times, if I integrate with respect to x, x equal to 0 to 4 and the top curve, when I rotate it around the line y equal to 2, the top curve will be the value of x, you're rotating it about y equal to 2. So it will be the top radius is x equal to 4. So it will be 4 squared and the inner radius will be this, that is 2 minus root x the whole square. This distance is 4, this distance is 2 and this is 2 minus root x. So minus 2 minus root x the whole square dx. So when you integrate it, you get 4 minus a minus b the whole square. 4 minus 4 root x plus x, that is pi times integral 0 to 4, 4 root x minus x dx. Integral of root x is x raised to 3 by 2 by 3 by 2. Integral of x is x squared by 2. So your answer is 40 pi by 3. So that comes to an end of the session where we have learned how to find the volume of the solid obtained by revolving a region about the x-axis or the y-axis or a line y equal to c.